Alright, so I'm just making you guys a quick little video to talk about what happens when we have the altitude of a right triangle. So, given this right triangle, and let's just put in some side lengths. So I could call it A, B, C. If I were to construct the altitude of this triangle, remember that's a segment that forms a right angle or a perpendicular bisector of the, in this case, of the hypotenuse, because it's directly across. And so it intersects that segment BC, forming a right angle, making it a perpendicular bisector. So when that's the case, similar to when we had an angle bisector, proportional relationships are formed. So for example, if I knew that this side was 6 and this was 8, and I knew that this whole distance was, let's call it 10. So if we know that, and this, remember, 10 represents BC, so that's the entire segment BC. So knowing that a proportional relationship is formed, if I wanted to find the individual pieces, X and Y, I could do so. Alright, so we can use a similar strategy that we did in our last lesson with angle bisectors by setting up a proportion such as 8 over 6 equals Y over X. And from there, we can use this idea of cross multiplication. So you end up with 8y equals, or excuse me, 8x, my bad. 8x, whoa, that was not intentional either. Sorry, 8x equals 6y. Okay, and then from there, since I don't want two variables in my equation, that doesn't help me solve, I'm going to eliminate y, and in its place, I'm going to replace y with 10 minus x. Okay, so again, we can now use the distributive property, and we would end up with 60 minus 6x equals 8x. I can add 6x to both sides, and I end up with 14x equals 60. And then from there, move all this up a little. Oops, that's not a good idea. And then there we can solve, and whatever that equals, what would that be? I don't have a calculator in front of me. 14 goes into 60, 28, 4 point something. So we know that in this case x equals 4 point something. Okay? So from there, and I'm just going to highlight, that really quick. So we know that x is going to equal 4 point something, and then I can use the same strategy of subtracting from 10 since I know that's the entire segment length. So in theory, 5 should be, or y should be 5 point something, and again, I don't have a calculator, so apologies. Okay? So that's again just an example of how to use an angle, or excuse me, an altitude, which is a slightly different from an angle bisector in that it forms this, and I'll just highlight in blue, it forms this right angle, or its perpendicular bisector. So just to be clear, the reason that it's different, or one of the reasons that it's a different relationship is, let me go here. So one of the reasons that it's different is if I drew a series of different right triangles, so maybe I have a right triangle like this, strike that, that won't work very well. So maybe I have a right triangle like this. And so again, if this is my right angle, you'll notice that the angle bisector here that would make this a right, it would be perpendicular, is going to be, it's going to form two different angles. So it's not an angle bisector here, but however it should, if it's an altitude, form a right angle by becoming the perpendicular bisector of the hypotenuse. So if this was A, B, and we're calling this side C, the hypotenuse, then we'll notice that that angle isn't a bisector and that it doesn't divide the right angle into two even pieces. All right, thanks.